Here I have a dataset on the prices of one-year-old used cars in 2005. You'll notice that each row has a different observation, in this case, a different car, and each column is a different variable. Minitab has automatically identified which variables are categorical by putting a T at the top of the column. According to the Federal Highway Administration, the average number of miles that Americans drive per year is 13,476. But I suspect that used cars that are on the market after just 1 year are more likely to be from rental car agencies, limo services, and other companies that put a lot of miles on their cars. So I want to test the null hypothesis that mu is equal to 13,476 versus the alternative hypothesis that mu is greater than that number, where here mu is the average number of miles on all one-year-old used cars in 2005. We're comparing one mean to an established value, so we should check the assumptions for a one-sample t-test. Looking in Minitab, my sample is size 20, so we should start by checking whether the individual observations are approximately normally distributed. We can do that by choosing the Graph menu, going to Probability Plot. We want a single plot, just one variable, so press OK. Then click in the box that says Graph Variables. Over on the left, all of the possible quantitative variables that you could choose will appear. We want a graph of mileage, so select Mileage, and then press the Select button. Then press OK. Here's our probability plot. All of the points fall between the curved lines, so it looks like a normal distribution is a reasonable approximation. So we're good to go to do a t-test. To do that, we can go to Stat, Basic Statistics, One Sample T. Our data is listed in the columns of our Minitab worksheet, and we have the raw data. So choose one or more samples, each in a column. Again, click inside the box, and a list of quantitative variables will appear on the left-hand side. Select Mileage, and then check the box that says Perform Hypothesis Test. We want to test the hypothesis that the mean is equal to 13,476. So the number that goes in this box should be the established value that's in the null hypothesis. That's our mu sub 0. Next, click on the button that says Options. Change the alternative hypothesis to match our alternative hypothesis. In this case, that was that the mean is greater than the hypothesized mean. In this example, we're not creating a confidence interval, so it doesn't matter what confidence level you put here. Then click OK, and click OK again. Here's our output from the one-sample t-test. We get the mean and standard deviation from our sample, and the p-value is shown here right at the end. In this case, it says that the p-value is 0.000. It's not really 0. It just looks that way because Minitab only shows 3 digits of accuracy. You don't want to report the p-value of 0 because that doesn't tell your reader of your report what level of accuracy Minitab gave you. Instead, you want to say that the p-value was less than 0.001. Or you could use the mean and standard deviation that Minitab gave you in order to compute a more precise p-value using your calculator.